Before we begin, we have to familiarize ourselves with what calcium nitrate and sodium phosphate are. Remember from the periodic table that calcium is in group 2A, which means that it has a positive 2 charge. Sodium, however, has a positive charge. We got those. Do you remember the polyatomic ions? We know that calcium has a positive 2 charge and nitrate has a negative 1 charge. When we merge calcium and nitrate together, we need to add a sub 2 for nitrate. This means that for every calcium, there are 2 nitrates. Same applies to sodium and phosphate. Sodium has a positive 1 charge, while phosphate has a negative 3 charge. We need to add a sub 3 for sodium. When calcium nitrate reacts with sodium phosphate, it produces sodium nitrate and calcium phosphate. We got the products, but how do we know which of the two is a solid, since the problem asks for a solid product? To do this, we have to consider the solubility rules. Let's check for sodium nitrate. From the table, we see that nitrate is a soluble compound and it has no exceptions, so it must be aqueous. But let's check calcium phosphate. Indeed, phosphate is insoluble. Phosphates do have exceptions, however, those exceptions do not apply to calcium. Now we know that when calcium nitrate and sodium phosphate react, they produce an aqueous sodium nitrate and solid calcium phosphate. We answered the first part of the question, and now we have to balance the chemical equation. An effective way of balancing an equation is by creating a table. I divided my table into the left side and into the right side. The right side is the side of the products, and the left is the side of the reactants. The left side contains 1 calcium, 2 nitrates, 3 sodiums, and 1 phosphate. The right side, or the side of the products, contains 3 calciums, 1 nitrate, 1 sodium, and 2 phosphates. The two sides are not balanced. We can multiply the calcium by 3 to get to 3. Don't forget to add the 3 into the coefficient of calcium nitrate. Notice that when we place the 3 before calcium, we change the amount of nitrates there is in the left side. We now have 6 nitrates. 3 times 2 equals 6. We balanced the calcium on the left and on the right. Now let's balance the nitrates. What can we do to balance the nitrates on the right side? That's right, we can multiply the 1 by 6. Don't forget to place the 6 before sodium nitrate. When we added the coefficient of 6 on the right side before sodium nitrate, we changed the amount of sodium there are on the right side. Now we have 6 sodiums on the product side. The left side still has 3, so let's multiply 3 times 2 to get 6. Place the 2 before sodium phosphate to balance the equation. Now let's check if our balancing is accurate.